Number 18 says, write a chemical formula for each example of molecular art. And you're given 3 examples. The idea here is that each of these balls represents an atom, and the different colors are different types of atoms. So I will point you to the figure 2.3, which you can see right here. It's in chapter 2 to identify what atoms they are. Now, everybody should know these 4 right here. You should memorize those: carbon, hydrogen, oxygen, and nitrogen. But every once in a while you'll see some other ones, so it's hard to memorize the other ones, but 96% of the human body are these, so memorize them. Now, looking at number 18, this one right here, you can see these are 2 chlorine atoms. And so we can write the formula as Cl for chlorine and 2. Make sure that you know the right symbol for the element. So Cl has the abbreviation Cl. Don't make a mistake and call it C or Cn or something. So get the abbreviations right. Now B, you can see here, 1 carbon, 3 hydrogens, and 1 bromine. So I would write the formula CH3Br. Now, I was given or asked a question through email. Does it matter what order the elements are? So can you write this, H3CBr or something else? And the answer is yes, you can. Now, there's a convention, usually in organic molecules. So I'll just say the organic convention is you will normally put the carbons first, and you have an X number of carbons, then you put the hydrogens first, Y number of hydrogens, and then O, I think, Z, and then maybe nitrogens, V, or whatever. That's usually what you see. But sometimes you see it in another order. So not always. So don't worry about it too much, but try to do it. However, there is one exception that is important. So C illustrates that exception. So that this is going to be, I'll just say an important exception. Okay, to the convention of carbons, hydrogens, oxygens, and nitrogens. Now, here, this is a complicated looking molecule. You have a hydrogen, an oxygen, a carbon, 2 hydrogens, a carbon, 2 hydrogens, an oxygen, a hydrogen. So you could count everybody up. You got 2 carbons. How many hydrogens? You got 6 hydrogens and 2 oxygens. Or we could write it like this: HO, CH2, CH2, OH. Okay, so I'm going to highlight that one because a lot of times you will see the atoms or the elements split apart. Okay, now this has the same formula as that, but this one gives you a little bit more information. Okay, you're clued in to how the atoms are connected. You see how they're connected here matches with how they're done there, and we'll use formulas like this and also more informative formulas like that, uh, you know, quite a bit in this class. Okay, but if you want to stick with formulas like this now, if you're not comfortable doing that, that's totally fine. But be aware that I'm going to be writing them like this quite a bit, and so learn to interpret them